Okay, the final exam review. One quick note. You are not in my class. You will find this video completely worthless to you. Do not watch it. So that warning aside, I decided to do the domain problem because it's one of the most complicated ones people have trouble with. So it's a great question because it combines the square root and the fraction, right? I mean, you did the domain of a fraction by taking the bottom and setting it equal to 0, figuring out the freak, throwing it away, right? That answer always had one or two numbers that just didn't work and you throw them away. Those domains were not intervals. The radical ones, you were throwing away all the numbers that create a negative inside there. So you have no choice but to write that as an interval. So the first thing you want to do is deal with the square root. Take the inside, set it equal to 0, and solve. Right, subtract 12. Divide by 6. I'm going to write all these steps. So you get -2. Now, you need to figure out which side works. So you can pick a number on either side. You can pick -3. You can pick 0. You can pick 1, 2, whatever. If you put -3 in here, you get -18. That fails. All those numbers don't work. If you put 0 in there, 6 times 0 is 0, plus 12, you get +12. If you were to plug in 1, you get 18. So all these numbers work. Now, -2 works also. Remember, square root of 0 is 0. This works. The number that gives you 0 works. And then all the numbers bigger than him out to infinity. You can erase your test point at this point. So that's it. That's the domain of the top. Now you got to take the bottom and set that equal to 0. Now I'm going to do this the easy way. I don't want to mess with negatives. So I'm going to add the 5x to that side. And then divide by 5. So you get 3. My 3 looks like crap. Try again. 3. So here's the catch to this problem. The domain of the top is all the numbers bigger than -2. They all work. There's no freaks there. Except there's a problem. There is a freak there. There's a freak hiding in here. The number 3, let's say it's about there. That he just doesn't work. He's going to create a 0 on the bottom. So he's trying to hide himself in all the numbers that do work, right? I mean, you threw away the freaks. All the numbers smaller than -2 were freaks. So we got rid of all of them. All the numbers bigger than -2 work, but the problem is he doesn't work. So you got to throw away that one guy. You got to put a hole there. So I need all the numbers from -2 to 3, but not counting 3. -2 is included though, right? Look, just take these two numbers and just put them right there. And then what? There you go, 3 to infinity. So this is the same way. This is taking all the numbers bigger than 2, except for 3. Everybody bigger than -2 works, except for 3. So you have to throw away that one single number. So it's always going to look something like this. If it was in the other direction, then you would have had negative infinity. That was the one on the practice sheet, right? But this is the one on the review sheet. So this is what you do. Domain at the top, get it done first, put it on the number line. Figure out which number makes the bottom 0. It's only going to be 1. And then throw that number away. Take your number line, put a little circle there and erase it, and then just those two numbers, boom. Those two, boom. See how easy? Just make sure there are parentheses here. Make sure he's included, right? He gets the bracket. All right, so that's the domain problem, 10 points. Okay, the fraction or rational function, finding the VA, HA, and X and Y intercepts. I mean, this you earn your 10 points on this one. It's not difficult, but there's a lot of parts to it. You could screw it up easily if you don't pay attention to what you're doing. The vertical and horizontal asymptotes are easier to do, so we'll do those first. The VA, remember what the vertical asymptotes are. They are vertical lines that represent the freaks, that break the function. So you take the bottom and set it equal to 0. You may as well just get rid of this 2, right? Factor the 2 out. If the product of two things is 0, one of them must be 0, but that one's not 0. So you don't need it there. So you get x plus 1, x minus 1. So you get x equal -1, x equal +1. Those are the vertical, right? It's the equation of a vertical line. X equal. Make sure that's there, because you have to, if you just write ±1, and I have to put the x there for you, it's going to cost you a point. Now the horizontal was easy. This is a horizontal line. That's why it's called that. That where the graph gets pulled toward, right? This is that dashed horizontal line. So it's y equal, right? It's the equation of a line. You got to put y equal. This is a line that goes left and right. This line goes up and down. So then what the trick was to take the highest power on the top and the highest power on bottom and just look at the numbers in front, right? You don't need the x squared, they cross out. So you get -4/2. So you get a horizontal line, y equals -2. Right? There's your vertical. There's the horizontal. I mean, that's like half the question right there. Now, x-intercepts and y-intercepts, which everybody forgot in class. The x-intercepts, you have to set y equal to 0. The y-intercepts, you just plug in x equals 0. That's the easier one to do. That'll take 2 seconds. Now, you got to be a little careful here because you have a fraction. You're setting y equal to 0. So you put a 0 here. Now, if you look at this, though, you already know that the bottom of a fraction cannot be 0, right? That's like the only major thing you cannot have is a fucking 0 on the bottom of the damn fraction. You can have anything else, it's not 0. So if you want this fraction to be equal to 0, right? X-intercept is where y is 0. That cannot happen if the bottom is 0. So this can never be 0. So basically, when you do that part of the problem, you just take the top and set it equal to 0. So when you do the vertical asymptotes, you're setting the bottom equal to 0. When you're doing the x-intercepts, you're setting the top equal to 0. Right? So this dude, you were setting the top equal to 0. This dude, you were setting the bottom equal to 0. I mean, that's how it goes. It's that simple. Now, this is a difference of squares. Let's factor it. It's 3 minus 2x, 3 plus 2x. Now I'm going to skip over this other nonsense, right? Set equal to 0, blah, 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 blah. You can't do this by now, right? You would subtract 3 and divide by -2. So you end up with plus or minus 3/2. Yay! Ooh, it's not right. Oh, what do you mean it's not right? I mean, it's right. Just the x and y intercepts are points. The asymptotes are lines. Vertical lines, x equal. Horizontal line, y equal. You just write a -2 there, it's going to be a -1 for sure. So you have to write these as points. You have to write 3/2, 0, and -3/2, 0. That's where this stupid ass looking graph, this graph is crazy looking probably. I'm not going to draw it. You don't need to draw it. But this is where it crosses the x-axis at those points. It is what it is. 1.5, right? 1.5, 3.5, 1.5, 0, and -1.5, 0. So the y-intercept is the easiest part of this whole problem. So you save it for last. All you do is go to the original function, and everywhere you see x, you put 0. I mean, I'll put the squares there. It's kind of a waste of time. This whole thing is 0. 0 squared is 0. 0 times 4 is 0. Same thing here. 2 times 0 is 0. So on top, you get 9. On the bottom, you get -2. Now, again, the y-intercept is where your graph touches the y-axis. It's a point. And you want to make sure that I know that you know it's a point. And the only way to show me that you know it's a point is to write it as a fucking point. Gee, rocket science. So there's a lot of pieces to this. I mean, it's a lot. Vertical, horizontal, x-intercept, y-intercept. So again, a lot of crap, but this is a single 10-point question. So you have to do all the parts of it. Just be careful with it. You watch your signs, you make sure you factor right. It's not super difficult, but you just know you have to know how to put all the parts together and answer it. Okay. So that was the last question on the review. Okay, for the sum ones, I decided to do 2 of them since I'm not going to have time to make a separate video for that. So this is on the practice. It's supposed to say sum of the first 80 terms. I got lazy. I was a little less lazy there. Just make sure that go up by the same, right? 3, 3, 3, 4, 4, 4. If not, it's BS. And if that were to happen, that would mean that I made a mistake because I'm not going to give you one that's BS for a 5-point question on the final. So your first step, right? That's the first term. That's A1. The first thing you need is the little d. We did the big D. And now it's time for the little d. So what's nice about them is that, one of them is going up and one of them is going down. So one of them, the little d, is going to be plus and the other one's going to be minus. That's why I'm doing 2 examples of it. Here, these are dropping by 3 each time, right? They're going down by 3. You're taking away 3 each time. So the little d, the common difference, is -3. On this one, they're going up by 4 each time. So the little d is 4. Again, the little d stands for the common difference. That's why these are arithmetic sequences. They're going up or down by the exact same amount every time. So it's easy to determine what the nth term is and what the sum is. So to figure out the formula, you need the formula. You can't do anything without this. So it is always the first term plus the little d times n minus 1. So I won't write it again when I do it over there. So the first term was -2. The common difference was -3. And now you just distribute the 3. -3 times n, and then -3 times -1 is +3. So my sequence formula is -3n, +3 take away 2 is +1. This is my formula. If I plug any number for n, I know my n looks a little weird. Whatever I put in for n, if I want the 30th term, I put 30 here and 30 there. That gives me A30. That's what the 30th term is. If I want the 80th term, and I know I'm going to need it, so I'm going to take 80 and put it in there for n. This is going to give me the 80th number in this list. If I were to continue writing that list out to 80 numbers, which is ridiculous, this is the number I'd get. This is -240 plus 1, which is -239. That's the 80th number in my list of numbers there. Now, if you want the sum, I realize I'm not going to have enough room. I wrote too much. I'll just erase it. So I want the sum of the first 80 numbers in this thing. So the way you do that is you take 80 times, well, you know what? I'll write the formula. You take whatever, I have to write that. It's the first number plus the 80th number all over 2. Right? This is what the sum would be. So I'm going to do 80 over 2 times the first number, A1, right, which is -2. The 80th number. Now you say, but there's a plus there. There was a plus there. But you're adding a negative. So you're subtracting them. Okay, so then you're going to do 80 over 2 is 40 times. Now this is -241, right? Just add, they both have the same sign, so add the numbers. Now, this is what you have a freaking calculator for. I don't know what the hell 40 times that is. So 40 times 241, and I'm just going to make it negative. So I get my sum is, see, I almost forgot the negative, -9640. Don't be a dumbass like me and just do it on the calculator without the minus sign there, and then you're going to copy it over without the minus sign. I kind of almost did. So positive times negative is negative. And it makes sense. You're adding a huge amount of negative numbers. You get a pretty big negative number. All right, so this is just a matter of you remembering the formulas. And no, I'm not going to tell them to you. You need to remember them. You need to know how to make the sequence. You need to know how to find the nth term. But that's easy. Once you have the formula, you just plug in whatever number is. But the sum, you have to remember that formula. Right, so it's always whatever this is. I think in class I called it K. Like if you wanted to sum from 1 through K, it was K over 2 times A1 plus AK. I know I wrote the K different that time. So that that would be the formula for the sum of from 1 to k. So I'm going to do the same thing over here with this one. So I realized I didn't have room, so I'm going to just move over here a little. So I want the formula. The formula is the first term plus the common difference times n minus 1. Common difference is 4. They're going up by 4. I know it sounds weird that you're calling it common difference and it's positive. So it's 6. Man, you do 6 plus 4 here. This whole fucking problem is over. 4 times n, 4 times -1, right? Order of operations. You do not add or subtract before you multiply. This is I've seen students do that, and then a whole question is shot. So just be careful. So then you have 4n, positive 6, take away 4. This is my formula. Now I want the sum of the first 60 terms. That means I need a 60. So I'm just going to put 60 right there for n. Replace the n with 60. So 4 times 60 is 240. Take away 2. So you get 238. That is the 60th number in the list of numbers. Were you to write them all out like a maniac, you would not. So then the sum from 1 to 60 is going to be 60 over 2 times the first number in the list, which is 6, plus the 60th number in the list. That's how it works. It's always going to be the first number plus whatever it is. If it's 80th, 80th number, 60th, 60th number, and then you divide that by 2. So this ends up being 30, right? Because you can divide 60 by 2. Cut 60 in half, you get 30. Add these together, you get 244. And then just multiply it. Right? 244 times 30. I don't have to worry about a negative number this time. So I got my sum to be 7,320. And again, formulas. Just know how to use the formula. It's not a difficult question. Make sure the sum makes sense to you, right? I mean, you could kind of see if the numbers are really ridiculously huge, the sum should be pretty big. I mean, if I made a mistake putting this in the calculator, remember, unfortunately, I don't have the graphing calculator next to me, or I'd show you. You can check the sum on the graphing calculator and just put the formula in and make sure it matches what you get when you do it by hand. If all I see is the sum, you get nothing. I have to see the formula. I have to see the 60th term. I have to see this. That's all the points. This is almost worth nothing. Maybe it's worth 1 out of 5, if that. All right, at this point, I'm going to start kind of jumping around a little bit. This is one that most people forget. I'm sure most of you forgot with the absolute value. Most of you will do this part perfect, right? You subtract the 2. Wow, it's so easy. And then what you'll just do is you'll drop the bars and you'll say 3 minus 5x equals 7. And then there goes half of your answer. Remember, absolute value is the distance to 0. So all it means is you take whatever number is in there and you make it positive. So that means the number that's in here, right? This number that could be inside of that absolute value could be 7. There could be a 7 there because the absolute value of 7 is 7. It could also be a -7. This number, it's just a number. So the number that's in there could be 7, or it could be -7. And you have to account for both possibilities. What if the number in there was -7? The absolute value, that's 7. -7 is 7 hops from 0 on the number line. So you have to solve 2 equations. Now, if you jump to there, this is the problem, that people don't drop the bars right and make the 2 equations. So you're going to subtract 3. 7 minus 3 is 4. And divide by -5. So you get a not very nice answer there. Or whatever. Now I'm going to subtract 3 again. This time I get -5 equals -7 and -3 is -10. Now divide by -5. Negative over negative is positive. 10 divided by 5 is 2. Those are the 2 answers. That's it. It's that simple. Just make sure when you drop the bars, you get a plus, you get a minus, right? The bars do not go here. You cannot put bars here. The absolute value cannot be negative. The number in there can be negative. But you can't have this. This don't make sense. There's no number that is -7 inches from zero, or -7 feet, whatever. This is nonsense. So this always has to be, if there's bars, this is plus. When you drop the bars, the number that could have been inside could be negative. All right, the outside number cannot be negative when the bars are there. All right, so now this one, log equation, it's simple, but it can be tricky because you forget this crap with the powers. All you have to do is convert it from log form to exponential form, and then solve it. So remember, this is the base, this is the power, and this is what you get. This is your answer. So that means that 16, the base, to the 1/2 power is, right, 16 to the 1/2 is equal to this. Very simple. And now, if you're a dumbass, you'll just go cut 16 in half, whatever. But it says half, I have to do half. That's a power. That's 16 divided by 2. Half, like we haven't done this 8,000 million times. The 1/2 power is a root, and it represents the square root. So you have to take the square root of 16, which is 4, and then you solve it from here. Subtract 19. I mean, at this point, it's very easy. So you get 3x. 4 take away 19 is -15. Divided by 3, you get -5. Now I'm going to show you real quick that it does work. If you put -5 in there, right, log 16. If you were to put -5, that gives you -15 plus 19. 19 take away 15 is 4. What power of 16 is 4? 1/2, right? 16 to the 1/2 power is 4. It does work. I mean, listen, don't check it. You don't need to check it, but I'm showing you what to do, okay? Convert it to exponential. Don't freak out about the fraction. Remember that it is a root. If it was 1/2, it's square root. If it was 1/3, it would be cube root. Pretend that this had been 8 to the 1/3 power. You would take the cube root of 8, which is 2. Right? I mean, easy peasy. This is not super difficult. All right, for 5 points, really. This is kind of a gift question. Shouldn't get it wrong. All right, so I decided to do the trig things together. One of them is to make the picture, which there's a video on that, but I'll do this one anyway. I mean, this is pretty simple. You have to draw it from 0 to 360. So before you even do anything, you should write the amplitude, right, which is the absolute value of 3, which is 3. You should write the period, which is 2 pi over b, right? There's A, there's B. So the period is pi. That tells you how long it takes to get one wave, right? Let's see, 90, 180, 270, 360. I'll fill in the numbers later. I know that this tells me how many waves I'm going to draw. Every 180, I get a wave of sine, one full sine graph, and I'm going to get 2 of them. 2 of them, right? The 2. As soon as you see this 2, the number in front of X tells you how many to draw. And if this had been negative, I would take the sine graph and flip it over, right? Flip it upside down. I don't have to go this time. So I know that I'm going to get, the sine graph looks like this. So I'm going to get half of it to here and the other half to here, right? I'm going to get one wave right there. So I'm going to make my upper bump and my lower bump. Pow. That's 1. I made it a little too low, but that's fine. So that's 1 full wave of sine. I need a second one because I have to make 2. So again, half of it here, half of it here. So make the upper bump and then the lower bump. And then put this big ass dot. And you have to label this. I prefer you do it in degrees. If you want to be cute with this and do radians, whatever, put 2 pi, 3/2 pi, this is 2 pi. Label it. The x-axis must be labeled so I know that you're drawing them in the right place. You get half of the sine graph to 90, the other half to 180. And then 1, 2, 3. There's the amplitude. 1, 2, -3. Make sure you label the y-axis too. All right. Drawing the graph is not that difficult. You just have to know how many waves to draw. And if you're drawing it upside down or not, make sure you know the fucking shapes. Don't draw a cosine if I ask you for sine. All right, it's not rocket science. Now, the trig equation, I taught you to replace the word with letters. And some of you are doing weird shit. Some of you are replacing it with a Y. Some of you are replacing it with an X. It's sine. I'm using an S. When it's cosine, I use a C. When it's tan, I use a T. I don't fuck around. I'm like, oh, let Y equal sine X, and then you put a Y there. This is just stupidity. I don't know why some of you are doing really dumbass things, and you shouldn't. You do what I show you. It's always easier. So even though the S can look like a 5, so you get 2S and S, has to be, right? You got to make 2S squared. Now, the only thing you can do to make it 2 is 2 and 1. So if you put the 2 here and the 1 there, watch, 2, 2. You don't get 3 out of that. That's not going to work. So I know that the 2 has to be here and the 1 has to be here. Now look, make the rainbow. There's 4. There's 1. This has to be minus. This has to be minus. I need the negative there to make the -3. Right? So you make the rainbow, or you can use the trick I showed you. That's fine too. But I'm just showing you. In this case, it's a little faster to do this. Make sure -4S plus 1S. I mean, I just erased it. I don't want to do it again. That's -3S in the middle. That's all you care about. 1 times 2 is 2. 2S and S is 2S squared. I know that works. So now, like I've said 80,000 times in the class, if the product of two things is 0, one of them must be 0. So you get 2S plus 1 equals 0, or S minus 2 equals 0. Subtract 1, divide by 2. Let's cut to the chase here. You get -1/2 sine X equals -1/2. Here, you just add 2. You get sine X equals 2. Now, if you want to lose points, don't write that. Write S equals -1/2. I don't know what the fuck that's supposed to be. That was to help you factor it. You are solving the equation sine X, angle X equals -1/2. You're looking for the angle. Now, what I don't want to see you do is put, oh, equal 30. -1/2 is not equal to 30. This, what you wrote is the equivalent of complete bullshit. Now, I do understand if you're trying to tell me that the reference angle is 30 degrees. That's fine, but then write that. Don't put sine X equal -1/2 equal 30, right? You have to write things properly. When I see things written incorrectly, I start taking points off for stupidity. It means that you don't understand what you're doing. So the reference angle for 1/2, right? You look on the chart that I am going to give you. I want you to have the chart so you'll have it. You look on the chart, you see that for half, it's 30 degrees. Then you figure out the quadrants that it must be in. Sine is negative in 3 and 4. Sine is not negative in 1 or 2. So I'm looking for 30 degrees in quad 3 and quad 4. So the angle X that I am looking for is 30 degrees here, which is 210. That's 180 plus 30. And in quad 4, it's 360, take away 30. So those are my two angles. Now here, I'm looking for the angle that makes it 2. Look on the chart, it ain't there. You look on the circle, it ain't there. This can't happen. I have said repeatedly, there's a 1 here in front, right? Sine and cosine are never larger than 1, and they're never smaller than -1. So it is impossible to get an angle that gives you 2. The sine of 30 is 1/2. Sine of 90 is 1. Sine of 270 is -1. You don't get 2. So that's just complete bullshit. So you throw that away. You only get this. All right. I'm going to do one more. Okay, the last one I'm going to do is the log equation. I mean, I know I have videos for all these, but I'm doing it anyway, so I may as well. Now, but there's a reason I'm doing this one, because I see something that's making me crazy, and I was nice enough not to take points off on the third test, but I will on the final. The first step of this question is to take the two logarithms that you have and use the log property to combine them into a single logarithm. So if you write this down as your first step, -1, that is not the first step of the question. And it's, again, this is laziness or not fully comprehending what you're doing. You just kind of memorizing shit and you just writing shit down, whatever it is. This is not the first step of the problem. First step of the problem, if you have two logarithms being added together, you can multiply the log of each, right? This was taking two logs. I mean, it was this property that the log of x plus the log, no, again, natural log. This was equal to the product of whatever you're taking the log of, right? That's the property. This thing on the other side stays there. Now, at this point, you're going to use another property. I said to you that if you had the log of x being equal to the log of y, right? I mean, if I told you had the log of 2 equals log y, that y can only be 2. What are you going to put there? 3? They're not equal then. The only way they're fucking equal is if the things are the same. So once you get to this point, you can drop the logarithms and say, okay, the log of a or x, the log of x equals log of y, then x and y are equal. So now you can drop, and I'm going to multiply at the same time. I'm going to drop my log now. I'm going to do x squared, negative 3x plus 2x, negative 3 times positive 2. Right? It's okay. Once this is there, you can drop the logs in the next step. If that's not your first step, points coming off. If the first step is you writing it like that, and I have to go back and put the L in there for you, like I did on 75% of your exams, well, then you're going to lose a point. And if you don't give a shit about the point, then whatever, then don't write it there. I'll just take the point off and move on. It's not going to, 1 point's not going to kill you out of 100. Remember, your final is out of 100. So now you got to set this equal to 0. So bring everybody on that side over here. Be very careful with the signs, because if you screw this up, got a big problem. Here you get negative 8x. 18 minus 6 is 12. Equals 0. Don't forget the equals 0, because if I write it for you, then I will charge you a point. Okay, so you'll never know because you'll never see your finals. So got to factor it. It's going to factor. Two numbers whose product is 12. You know, and if you're not sure, you can write them all down. There's not many. 1 and 12 won't make 8, right? Add and subtract them, you don't make an 8. 6 and 2, 6 plus 2 makes 8. 3 and 4, they make a 1 and a 7. So that's out. That's out. Got to be 6, got to be 2, and they have to be the same sign. How do I know that? Because I have a positive 12. These must be the same. They're either both plus or they're both minus, but they can't be plus because this is not plus. You get negative 6, negative 2 makes negative 8. All right. It's important you factor right. Some of you are a little rusty with the factoring. Some of you don't do well. I also want to point out, I see you factor by grouping. You're going to lose a point. This is bullshit. We don't do this. There's a 1 here. Not factor by grouping when there is a 1 there. I don't want to see you split this middle term up into 6 and 2, because if you do that, you already know the answer. So it makes no sense to do this. All right. Now, if the product of two things is 0, one of them must be 0. So we're at the point we can do this in our mind. Get 6, you get 2. Now you got to remember, you look back in the original. 6 plus 2, positive. 6 take away 3, positive. 7 times 6 is big, right? 42 minus 18 is positive. Now put 2. 2 plus 2 is positive. Yay. 2 minus 3. Uh-oh. And this is where you run into the problem. You cannot take the logarithm or natural log. You cannot take the log of a negative number. It is undefined. It's another BS thing. So this does not work. Make sure, please, to make me happy, cross it out and write BS, bogus solution. So I know that you know. How else do I know? If you don't write the BS, maybe you made a straight 10 mark there. Maybe you just made an accident. How do I know? I don't know you're rejecting that answer unless you either write reject, extraneous, which is bullshit. Don't you dare write that. Or BS. I mean, nothing is faster than writing BS. So if you get the answer that fails, you're going to get 2 positives. It's very easy, if you're doing a question like this and you get x equals 6 and x equals negative 1, you're like, throw away the negative 1. That's easy. But when they're both positive, you got to take a second to think which one doesn't work. You're going to get 2 answers. One of them is going to fail. This is a fact. All right. So now look, the rest of this test, composition of function, it's a joke. Again, go back and watch that video. The exponential growth and decay, you're only going to have one of them, right? It'll either be decay or it'll be growth. You find your rate, you write your function down. Again, this is not difficult. Those are not hard questions. The rest of this stuff is all pretty straightforward. All right. I don't think it's a difficult exam. And then you have the graphing calculator one. Just make sure, the max and the min are Y values. And then the zeros, there'll be 3 of them because I gave you a cubic polynomial. So it's going to be a roller coaster. It's going to go up, down, up. So you'll have a relative max, a relative min, and you'll have 3 zeros. So that question is worth 10 points all by itself. A max and a min, 2, 2, and then 3 zeros, 2, 2, 2. So that's 10 points, 2 points each. So just be careful that you're pushing the right buttons. All right. So this is everything. All I can really do is wish you good luck on your final. Just be prepared. Show up unprepared to a test, bad things happen.